Look up on a clear day and you might see them. Long white lines stretching across the blue sky, slowly spreading, sometimes crisscrossing like invisible highways overhead. They can appear suddenly, linger for hours, or fade away within seconds. For something so common, they've sparked an incredible amount of debate and speculation. So what are they really? Today we're exploring a question many people have quietly wondered about. Why do planes leave white trails in the sky? Let's break it down and uncover what's actually happening above us. Right here, on History of Simple Things. The white trails behind airplanes are known as contrails, short for condensation trails. They form behind aircraft flying at high altitudes, usually above 26,000 feet where commercial jets cruise. At first glance, they may look like smoke, but they are not smoke in the traditional sense. Instead, they are narrow clouds made primarily of ice crystals. The key to understanding contrails is recognizing that they are essentially artificial clouds created by aircraft under specific atmospheric conditions. They only form when temperature, humidity, and engine exhaust interact in just the right way. Without those ingredients, the sky would remain clear behind the aircraft. Jet engines burn aviation fuel, and like most fuels that contain hydrogen, combustion produces water vapor as a byproduct. When the engine burns fuel, hydrogen atoms combine with oxygen in the air to form water. At cruising altitude, the surrounding air temperature is often below -40 degrees Celsius. When the hot exhaust gases containing water vapor are released into this extremely cold, low-pressure environment, the vapor cools rapidly. The rapid cooling causes the water vapor to condense and then freeze into tiny ice crystals almost instantly. These suspended ice crystals reflect sunlight, making the trail visible from the ground as a bright white streak. A helpful comparison is visible breath in winter. When you exhale warm, moist air into cold surroundings, the water vapor condenses into tiny droplets, forming a mist you can see. Contrails form through a similar process, except instead of droplets, the water freezes into ice crystals because of the extreme cold at high altitude. The difference is scale and altitude. While your breath disappears quickly near the ground, contrails form miles above Earth where air pressure is much lower and temperatures are far colder. The physics is the same, rapid cooling of moist air, but the environment determines how long the cloud remains visible. Not every plane leaves a long-lasting contrail. Sometimes the white trail fades within seconds. That happens when the surrounding air at flight altitude is relatively dry. In dry conditions, the ice crystals quickly sublimate, meaning they turn directly from solid ice back into water vapor without becoming liquid. When sublimation happens faster than the crystals can accumulate, the trail disappears almost immediately. In contrast, if the upper atmosphere is humid and near saturation, the ice crystals persist. Additional moisture in the air can even deposit onto the crystals, allowing the contrail to spread and widen. This explains why contrails behave differently from one day to another. Under the right conditions, contrails don't just linger, they evolve. Winds at high altitude can stretch and spread the ice crystals horizontally, transforming thin lines into broader sheets that resemble cirrus clouds. In fact, persistent contrails are nearly indistinguishable from naturally occurring cirrus clouds because both are composed of ice crystals. Scientists refer to these as contrail cirrus when they grow and merge into larger cloud formations. These high-altitude clouds can subtly affect Earth's energy balance by trapping some outgoing infrared radiation. While their climate impact is smaller compared to carbon dioxide emissions from aviation, researchers continue studying how frequent air traffic contributes to additional high-level cloud cover. Because contrails can linger and spread dramatically, they have fueled misconceptions over the years. Some claims suggest they are chemical dispersals rather than condensation trails. However, decades of atmospheric science research explain contrails using well-established thermodynamics and cloud physics. Their formation depends on temperature thresholds, humidity levels, and engine exhaust properties, all measurable and predictable factors. Military and civilian aviation researchers have studied contrails since World War II, when they were first observed interfering with aircraft visibility during combat missions. There is no credible scientific evidence supporting the idea that routine commercial contrails are intentional chemical releases. They are visible evidence of combustion and atmospheric conditions interacting at high altitude. The next time you look up and see a plane leaving a white trail across the sky, it's easy to let your imagination run wild. But what you're really seeing is the atmosphere responding to a simple mix of heat, moisture, and cold. Those trails form when water vapor from the engines meets the frigid air at cruising altitude, creating ice crystals that briefly make the invisible visible. Contrails aren't mysterious or secret. They're a clear reminder that even something as routine as air travel interacts with the natural world in real time. They reveal the dynamics of the sky in a way we rarely notice, showing how delicate, responsive, and constantly changing our atmosphere really is. And once you understand that, those white streaks stop being puzzling curiosities and start being a quiet demonstration of science at work right above us. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.